Hello and welcome. We're going to look in this video at the objective 3.85, which is construct and solve an inequality from a word problem describing geometric situation such as designing a box or a juice can. We're going to talk about this case, and this is an application of the lesson solving inequalities in one variable. So our problem is here. So I would like you to pause the video and try to read the problem, figure out the situation, and see how much you can do. Okay. So this is our problem. It's about a tomato juice cylindrical can, which looks like this, which is in the shape of a cylinder. The volume is given 2 liters, which is equivalent to 2,000 centimeter cubed. That's your volume. We are required to find the radius, to find the height of the can, so that the surface area is less than 1,000 centimeters squared. So what is our problem? This problem, we have to deal with the cylinder. The volume of this cylinder is given 2,000 centimeter cubed, and we are required to find the radius and the height. Let's call R the radius and H the height. So our cylinder looks like this. This is our radius of the base, which is a circular base, and this is our height. Okay. Now, what is the surface area? The surface area formula is given by 2 pi r squared plus 2 pi r h, which is actually the surface, the area of the base, this base, which is 2 pi r squared. And because you have 2 circles, one at the base at the bottom, one at the top, so you have to multiply this by 2, and that's why we have this 2 pi r squared, which is double area of the base. And this 2 pi r h is the lateral area, the surrounding one. If you open this can, or you create a net for this can, you get it on this form for the cylinder. The net of the cylinder looks like this. I'm going to show you how it looks like. So this is the lateral face, the surrounding, and this is a circle, this base at the top, and this is another circle, the base at the bottom. The radius is R. Okay, so the surface, the lateral area is the area of the rectangle. This rectangle has length and width. The width is h, which is exactly this height. And the length is the circumference of the area, 2 pi r. 2 pi r is the length of the rectangle, h is the width. You multiply them, you get the area, and that's why we have 2 pi r h. You don't need to do all this, you just need to remember the surface area. It's just to explain to you where do we get it from. Now let's go back to our problem. So as I said, this is the formula of the surface area. Why do we need the surface area in this problem? Because in the problem, the given information is the surface area should be less than 1,000. That means we have to include the surface area in our problem. This surface area should be less than 1,000. Okay. Now, we can see that our surface area contains 2 variables, R and H. Okay. So we have to eliminate one of these 2 variables, either R or H. Okay, so we have 2 variables, as you can see, this H and this R. I cannot solve a problem with two variables, so I would like to make it to eliminate one of them. And that's why I need to use the volume formula for the cylinder, which is pi r squared times h. And then I solve for h, because I want to eliminate. It's like solving system of equations by elimination. It's exactly the same, if you remember. So I'm going to find this h by dividing both sides by pi r squared. Okay? Divide each side by pi r squared, and you get your h. Now we substitute this h in this formula. Exactly like solving system of equations by elimination. I'm going to eliminate the variable h. So in my formula of the surface area, I'm going to substitute this h by v over pi r squared. So I get the h here. It's exactly the same formula here. And then I can simplify. Can you see that we can cancel this pi with this pi and this r with one of the r's in our square? So we get only 2v over r. This is after we simplify. Now, we can use this to solve our problem. In case you face a similar problem, you don't need to do all the work I have done here. You can just memorize this formula for the surface area. It does exist actually in one of the rules. Okay? So memorize it, formula in terms of the volume and the radius only. Okay? So you can memorize this, but make sure you also know that you have to use the h as well, relation between volume and height. Now, let's start our problem. We have the surface area, as we said, and the volume is given equal to 2,000 in the problem. Actually, here is the problem. That's our volume. It's given 2,000. So I'm going to substitute this v, the volume, by 2,000. So if I substitute by 2,000, I get 2 times 2,000, which gives me 4,000. So this is what I'm going to use. Okay? Now, back to our problem. In our problem, they require the surface area to be less than, surface area should be less than 1,000. And that's why we have to put surface area less than 1,000 using the formula, this formula. We get 2 pi r squared plus 4,000 over r less than 1,000. Now, we focus here, we do some calculation, divide by 2, because I have multiples of 2. I can divide this by 2, and this by 2, and this by 2. So I get this simplified form. This looks like a horrible rational inequality. However, I know in your book they solve this graphically using a graph of a rational function and a line y equals 500 if they don't simplify. If they don't simplify, they use the other one. Okay, and then they see where the graph is under the horizontal line of equation y equals 500. However, here, I'm going to solve it using polynomials. How? Going to multiply each side by r to eliminate the fraction. Which fraction? The fraction 2,000 over r, this fraction here. So I multiply by r, okay? And this r, I know as a fact that it's a positive value. It's a radius of a can. Make sure you know you're in a situation where r is a radius, and the radius cannot be a negative value. So when I multiply by a positive value, r positive, the inequality will be maintained. I'm not going to change the direction of the inequality. It stays the same because I multiply by positive. So when I multiply here by r, here by r, here by r, and here by r. So I get by r cubed, and this r cancels with this r. I get 2000, and here 500r. So this is my simplified form. As you can see, I don't have any rational inequality. This is being transferred to a polynomial inequality, which can be actually tested. You can be tested for, because if they test you for polynomial inequalities, they can include this problem. Okay, as you can change it to inequality involving the polynomial instead of rational. We rearrange it, we get this expression. Okay, it's just moving 500r to the left with a negative sign and write it down in standard form. Now, to solve this inequality, we need the zeros for the cubic, which are the solutions of this equation. You can use your calculator, mode 5, and then I think it's 4 for the cubic. And you enter A, B, and C, and D. Make sure B is 0. I hope you know why. Because I don't have in the polynomial coefficient of r cubed. Br cubed doesn't appear, br cubed squared. That means the B is 0. Okay. After you enter it in your calculator, can you try to check and enter it, pause the video, and try to do some work. Okay, you just enter A and B and C to get zeros. You get to get an approximation of the zeros anyway. Okay, so all the solutions that we get here are approximately true. Cannot have accurate zeros. So you get solutions to be rounded to these values. Okay, 1, 2, 3 solutions. Cubic, usually you get 3 solutions or sometimes 1 solution when you have a graph like this. I hope you still remember. So if you have a graph like this, there are 3 solutions. If you have a graph like this, there are 1 solution, and you might get 2 solutions if you have a graph like this touching here. 2 solutions, one of them is double with multiplicity equals 2. These are different cases, of course. This is when A is positive. In our case, A is pi. Now, never mind. Don't think about all this. This is just to extend your knowledge, just in case you are wondering. Now, let's go back to our problem. So we start our sign chart. I have this line, I have the zero set on the line. This 0, we have this negative 0 here. That's your 0. And this is another 0, and this is another 0. As you can see, I put them on the number line. What is this? This is the minimum value of r. Actually, it's not a minimum value. R cannot take a value 0, but I just put it here. It's like a boundary for r. Okay? Because r is a radius, it has to be more than 0. What does it mean? It means that in our situation, we don't care about what happened before 0 for r. This line is line for r, okay? Not x. We don't have x in this problem. We have r. The independent variable is r. The function f of r, not f of x. Can you see? I put it here, f of r. So my independent variable is r. So this line is for r, this number line. Okay? So r cannot be less than 0. So all this, I ignore it, this part. Okay? So I'm going to focus on this side. So let's find the sign. To find the sign, I put my function f of r. And into your calculator, Where did I get this function from? It's from the inequality. Can you see this inequality? I want the sign of this expression. So I need to use a function to substitute in. So this function, put it in your calculator. Okay, just type it using alpha. Of course, in your calculator, there is no r, so you can use x. Okay? And then substitute with these values, 1, 5, and 10. You get these values, and you get the sign, positive, negative, and positive. You ask me why these values? Very simple. The first value, 1, f of 1, is here. This is your 1. Okay? Why I choose 1? It's any value between the minimum value of r and 4.6193, the 0. You can take 1, you can take 2, you can take any value between 0 and 4.6 something. I took 1, it's very friendly. Then, why do you take 5? 5, it's after this 0 and before this one, in between. So I have chosen 5. You can choose 6, 7, 8. Okay, any value between these two zeros. And then, why I have chosen 10? 10 is somewhere here, after 9.6, to see what is the sign. So we have the sign up. What do? You put the sign on the number line. Okay, let me clear this. So what is the sign of fx? The sign between 0 and 4.6, we found it positive, so we put positive here, and then negative, and then positive. Okay, this is our sign. Now, let's go to our problem. I've summarized the sign here. Okay, so this is positive, this is negative, this is positive. This is the summary. Now, the solution of f of r less than 0 are the values between the two zeros, which are here, these values, where f of r is negative, between these two zeros, 4.6193 and 4.6549, etc. So these are my values for r. Why I'm looking for this? Because the problem, let's go to problem. Problem here says the surface area is less than 1,000. When I started with my surface area less than 1,000, I reached my problem, I reached here. I reached this inequality. That's what does mean, less than 1,000. I reached this inequality, so I'm looking for less than 0, f of r less than 0. This is what I'm interested in, and that's why these two zeros, okay? This 0 and this 0. So I can write this as an inequality, a double inequality, 4.61, etc., and 9.65, and so on. So I write here for you. Here it is. Okay? Now, the question is asking about the radius and the height. Look at the problem. It says find the radius and find the height. So we found the radius, we need to find the height. There is a relation between the height and the radius, this formula here. We stated it at the beginning of the problem. We will use this that we found earlier to find the values of h. So we substitute v with 2,000, which is given in the problem, into this v. So we get 2,000 over pi r squared. This is our h. Now I'm going to start from the r, the results that we got for r. And then I square it. Why? Because I have r squared here. So I need to square each side. As you can see here, we square each side. We square r, we squared two boundaries. Okay. And then multiply by pi. Why do I multiply by pi? Because I have here, as you can see, this is my h. I'm interested in this h. Make sure you remember that I am looking for this h. So in this h I have r squared times 2. R squared times pi. And that's why I have to multiply everything by pi. So I multiply here by pi, here by pi, here by pi. Now I have r squared pi. I need it in denominator, so I have to take the reciprocal. Okay? When I take the reciprocal, I have to reverse the inequality. So whatever is more becomes less. Okay? This becomes less. And I take reciprocal of everything, as you can see here. Okay? 1 over any value I have in my inequality. Why do I do this? Because I have over pi r squared. So I need to divide by pi r squared. 1 over, and then I multiply by 2000, and I get my h. Multiply by 2000 every single side. Multiply here by 2000, and here, and here. Okay? I am maintaining the inequality because I multiply by positive. So, now we reach the expression for h. This is the expression for h. I substitute it as h. Here we are, our result. Enter into your calculator these fractions and see how much you get. You're going to get these values, okay? And these are values of h. What are the results? R must be between 4.6193 and 9.6549, etc. And h should be between these two values. These are the results of this problem. Conclusion, we have to make it or put it into the context of the problem. The surface area of the cone will be less than 1,000 as required if its radius is between 4.62 centimeter and 9.65, of course, approximately, and the height, h, is between 6.83, we have to round this to 6.83, and 29.84. This is the rounding for our answer. The book got a different rounding because they got a different answer, you don't need to worry. And for any particular cone, h must be 2,000 over pi r squared. That's the h that we have to calculate. So this is it. Thank you very much.